Continuing with our introduction to the mole, I have this little model that shows you how to change the number of moles times the particles to find out the total number of particles. So the number of moles, say I start off with 1 mole. 1 mole has 6.022 times 10 to the 23rd particles. And this unit is equal to 1, the number of particles in 1 mole. And then I can compute the number of particles. So in this case, it's just 1 mole, so it's 6.022 times 10 to the 23rd particles. If I look at my analogy, the moles is just a bucket full of particles, okay? I got a carrying case here, 1 mole of particles. In here, I've got this many particles. I could carry that around, or I could carry a dozen eggs around. This would be a dozen eggs. That's my little carrying case, and I'm just counting 12. 1 dozen eggs goes into, there's 12 eggs per dozen, and so I can compute there's 12 eggs. So I go from 1 dozen to 12 eggs. So I went from my total, my big number, into my units, my individuals. And I can also go back the other way. If I start off with a number of particles, if they give me a big number of particles, I can compute how many moles there are. I'll need to do this for some of the chemistry analysis that we're going to be doing. So I start off with a number of particles, so I go down this way, and all I do is flip my unit changer, and as you can see, I'll have 1 mole of particles for every 6.022 times 10 to the 23rd particles. I'll have 1 mole. And so I can go back and I can figure out how many moles. My particles will cancel and I'll end up with moles. So either way you go, you're going to be able to figure out the moles in one case and the number of particles in the other case. Remember, it's just the number of particles. It's a number of things.